The METUS Tech Show.
Welcome to the METUS Tech Show, a show for HVAC professionals by HVAC professionals.
I like how you guys bounce back and forth between heat pump talk and food talk.
The METUS Tech Show.
Mitsubishi.
All right, so we are at the 2026 National Sales Conference, and we're just outside of Denver, Colorado. For all intents and purposes, it's Denver. So I decided to look up what kind of foods are popular in Denver. And the first one that came up is the first thing that comes to mind for me is Rocky Mountain oysters.
Rocky Mountain oysters.
Now, yes, we're no way near the ocean.
Right.
So when I first heard that, I go, how can you have oysters without an ocean?
Well, there could be freshwater oysters.
Well, there's no such thing. And if there is, don't eat them. Okay? But Rocky Mountain oysters are just breaded and fried bull testicles, often served with horseradish sauce.
Really?
Yes. So no thank you.
No.
No. I mean,
I'm a second no.
you see, I was thinking buffalo wings are not really wings from buffalo.
Right.
From buffaloes. So
Exactly.
maybe Rocky Mountain. No. So no. So let's move on because
Yeah,
that's all I'm
please.
going to say about that. Green chili is popular, and yesterday when we got here, I had this chimichanga, and it had this green chili on it, and it's just the Colorado style. It's a stew-like fiery sauce made with Pueblo chilies, used as a staple topping for burritos, burgers, and fries. And let me tell you, if it's anything like the one I had yesterday, it's delicious.
It is delicious.
It was awesome.
It is somewhat spicy, but it's
Very
delicious.
I like it spicy. And then something I didn't know about Colorado-style pizza is a thick crust mountain pie, popularized by Bo Joe's, must be a place in town, with a braided edge served with honey for the crust. Wow. That sounds delicious. I didn't know Colorado had its own pizza.
So, Will, are you a pizza person?
I enjoy pizza. My family enjoys pizza. We make a pizza night once a week. So that is a staple for us.
But by pizza night, are you ordering pizza, making pizza?
Sometimes we'll make it.
Yes.
And sometimes we'll order it. It
Okay.
depends on the mood.
When you make it, do you make your own dough from scratch?
Yes, but I buy the box.
The box what?
Well, it comes with the, pre-mixed pizza dough.
So you don't grind the wheat.
I don't grind the wheat.
Yeah.
I do not mill.
Yeah, Mark.
I do not mill.
Mark was on last week. He grinds his own wheat. I'm like, okay, this guy is just too much for
I
me.
wonder if he does the harvesting
Yeah,
too.
he probably grows his own wheat. Yeah. All right. So, and then bison and game meats was tender and lean meat, frequently ordered as burgers or sausages, often found at whatever Buckhorn Exchange. The Denver omelet, I think that's popular everywhere.
Okay.
It's the omelet that I usually get. It's just an omelet with diced ham, onions, and bell peppers. But I add
That sounds
cheese.
good.
I had American.
yes.
I had American cheese.
Cheese goes with everything.
To that, and there's something called the slopper, which is a cheeseburger smothered in green chili, famously served at local diners. And
And they slap you with it.
yeah, that sounds very good. How far are we from Mexico?
We are far.
Okay, because the next thing you hear is a Mexican hamburger, which I'm willing to bet you they don't serve anywhere in Mexico.
Not even close.
It's a burger patty wrapped in a tortilla with refried beans, and smothered in green chili. That sounds
great.
delicious too.
Yeah, Paul likes tortillas and fajitas.
Fajitas
That's
and
right.
tortilla.
You can get both of those at Chipotle. Right? And then the last one is Colorado lamb. It's known for high quality, locally sourced lamb dishes. I'm guessing there's a lot of lamb livestock
Could be.
around here. Like Wyoming has cows. I guess Colorado might have lambs. And when you got lambs, you're going to eat the lambs. Take their wool.
I'm sure they have plenty of mountain oysters too.
Yeah, no, it's just no. Why? Whose idea? Okay, whose idea was it? Who's the first person to
I
say?
have no clue.
Hey, let's fry these up and see what they taste like. I don't get it.
Yeah, no.
Like lobster. Lobster used to be a poor man's food, right? Back in centuries ago,
Right.
they had prisoners riot because they were fed lobster every day because they would just wash up on the shore. So somebody looked at a lobster one day and said, "I wonder what this tastes like." and decided to cook it and figure out how to eat it. And I just,
You
I
don't like
love
lobsters?
I love lobster.
Okay, I do too.
But this is, I grew up,
Okay,
you're
I
introduced to
gotcha.
it. But the first person to try and cook a lobster, what were they thinking? The first person who cooked Rocky Mountain oysters, what were they thinking? I don't get it.
I know.
Anyway, welcome everybody to the METUS Tech Show. My name is Paul Shavs. Joining me today is once again Juan Cardona. Juan, say hi.
Hola.
Hola. And I think this is your second time on.
It is.
William Ross, say hello.
Hello. Great to be here.
And just for those people who don't remember or don't care, where is your training center?
I am out of Orlando
Orlando. And you've been with us how long?
since February.
Since February, all right? So you're fairly new. You've been here a couple of months, few months. And we're going to talk about circuit boards. So I think we're going to call this episode "Don't Be a Parts Changer" or something in there. We find that a lot of boards come back,
Yes.
and there's nothing wrong with them.
Yeah,
We just had a case recently, and I'm not going to mention names or be any specifics, but somebody had no voltage coming out of a board, and they said, "Oh, I'm going to replace the board." Had they been to training, had they looked in the manual, they would have found that there's no voltage on those pins on that
Yeah.
board. It's not supposed to have
Yeah.
voltage. So, and then Steve had the idea. It's a great idea. He couldn't join us. He's actually in one of the breakout sessions here at the conference. He put together what I think is going to end up being a series because we can't do this all in one
Right.
episode. Control boards.
It's a lot. Yes.
Yeah. So before we get into the control boards, let's talk about in high level general terms and not anything equipment specific, but what are the basic boards we're going to have in most of our units?
Well, typically it's going to be the noise filter,
Mhm.
the control board, the inverter board, MNet board. So it could be 2, could be 3. Some models have 4.
Yeah. Let's stick with the three, what am I going to call them? The core boards. Let's stick with the control board, the inverter board, and the filter board.
Yep.
Yeah.
Right. So one of you guys want to just tackle on a high level in general terms how the electricity flows through each board and what each board does.
Yeah, so we're going to take incoming power to our noise filter board, and that's going to remove any improper frequencies out of the electrical circuit. And it's crucial because as we're approaching our inverter board, the whole purpose of our inverter board is to soothe that electrical circuit and turn it into a DC sine wave. So if we have impurities in there, it's just going to cause our sine wave to be out of whack. The control board primarily is just going to be used as what it sounds. It's going to control the rest of our circuits, and it's going to provide communication between our indoor and outdoor systems.
Right, and that's typically where all the LEVs, all the thermistors, all the pressure transducers, or we call them pressure sensors, they all plug into the control board, and that is the central command center is what I like to call it.
So this control board is taking in all those inputs, all that information. It's basically a computer. Guys,
is.
all three of us have a laptop in front of us right now. If we were to take that laptop and smash it into bits, it would look like what our systems look like. You'd see
Yes.
printed circuit boards.
Yeah.
Right? Not a motherboard, but we'd see a control board, at least a control board, an inverter board, and a noise filter board. And the noise is very important, but I think we're going to start today with the control board. So in simple terms, the circuit board just decides what the heat pump should do. It tells each component how to do it, and it shuts things down if something isn't safe, based on everything that it's getting as an input.
Yeah, typically when I start my classes, I always ask, what component sends the command to run? So they're all stumped. I said, it's the wall controller or the central or the handheld controller.
Right.
And then I ask, where does that command go to? And some will say outdoor unit. Well, no, it goes to the indoor unit. And then, yes, it eventually gets it to the control board at the outdoor unit, and then that decision is made.
So that's an important distinction that you just made. We don't have thermostats. We have controllers. So a thermostat is a switch that opens and closes based on its sense and temperature.
Correct.
Yes.
But a controller does not open and close a switch. It sends a command. It's going to send 1 and 0s somewhere. And if I had a controller and I hook up the 2 wires to it, because that's all it is,
Right.
or I have a handheld one, once I send a command, that command is gone. I can disconnect those wires, and that command stays there.
Stays there.
Correct.
It's gone. And I say this because They did this in my house when they put it in. They put a float switch. My air handler's in the attic, and they put a float switch in it, and they had the float switch break one of the wires, the 2 wires from the controller to the indoor.
Yeah.
That's not going to do a thing.
No.
Because the command says, I want cooling.
Yeah.
Cooling is on. That float switch opens, nothing happens. It doesn't shut anything off.
A very common misconception with some of the mini split products, including our own, is that you can break the controller. You cannot break the controller. Once the command is sent, it's stuck there until it is either told to be removed, or you cycle power, or we give it a new command.
Right.
And so, but in conventional refrigeration, a lot of times we're breaking the thermostat. We're going to break or we're going to break our call for cool on some heat pump models. And it's very easy for guys to just, disassociate those two things.
Yep. So we're not going to get equipment specific. One of you guys mentioned that it could be 1 board, it could be 2 boards. I think Juan, you said it could be 3 boards. Right. And there are other boards that could be there. We're going to stick with this episode. I think we're going to do a series. We're going to do a series. We'll stick with a control board. Next week, we'll do the inverter board. And then the week after, we'll do the noise filter board. Right? But basically, the control board is just going to control the indoor-outdoor communication. It's like I said, it's going to be monitoring, you mentioned, Juan, the temperatures, the pressures, the operating conditions. It's going to look at the inverter speed. It's going to look at the fans, LEVs, like you mentioned. It's going to do something if it senses that something's not quite right. It's going to throw a fault code of some kind, whether it be lights, LEDs flashing, or a pneumatic value.
And the communication is a voltage that's measurable.
Correct.
Because it's not just ones and zeros or I's and O's.
Right.
It's an actual voltage that the circuit board uses to communicate with either the thermistor or the pressure sensor or whatever it is on that line. It's a measurable voltage.
Yeah.
Go ahead, Will.
No, I'm sorry. Between S2 and S3, we should be reading 30 volts DC across there.
If we're talking
pulsating voltage.
If we're talking about an M series, M and P series equipment, but regardless of what equipment we're talking about, whether it's M and P series, whether it's City Multi, the boards are going to do the same thing. They're going to take incoming power.
Yes.
They're gonna cut off the bottom part of the sine wave. They're going to create a DC voltage. They're going to take that DC voltage and they're going to create a simulated variable frequency, variable voltage, simulated 3-phase power. So again, we're sticking with a control board for now.
And that voltage communication that I'm talking about is, again, the thermistors are connected to the control board.
Right.
So that voltage is an output from the circuit board into the thermistor. And then depending on the temperature, it reflects back a resistance value, which the control board reads and knows what temperature that thermistor is reading. So it's you may be getting a fault on a specific thermistor, but then you test the thermistor, and the thermistor may test good, but then you need to make sure that there's voltage at the pins where that thermistor is plugged into.
Right. And the thermistor is nothing but a resistor that changes resistance with a change in temperature. Yeah. And it's a solid-state device. If it's a positive temperature coefficient, then as the temperature increases, the resistance increases.
Yes.
In the manuals, in the FMs, you can look at charts that tell you what you should have at a certain resistance and what temperature that should translate to.
Right. And plus we have episodes on proper testing of the thermistors.
And on those episodes, we mentioned, hey, those thermistors are out in the elements, a lot of them, or they're on a coil that's going to change temperatures and moisture and dry and so things. So it's a part that you would probably want to stock on your vans or at least in your shop.
Absolutely.
Right? So let's go back the control board. Let's take incoming power. What do we need to know about the incoming power? Again, let's keep this equipment agnostic and just speak in general terms.
Yeah, we should be getting 240 volts AC power to our indoor units on normally S1 and 2. And then we'll have S3 also, which would be a communication wire, and that is going to be receiving our low voltage signal.
Yeah, regarding incoming power, you want to go to L1 and L2 because there's a range. Sure. Typically, the equipment is rated at 208, 230. You take plus or minus 10%.
Yes.
So the actual range is going to be between 188 and 253. And I share with the students that whenever that voltage is at both extremes, the inverter board reacts to in a certain manner. But if that voltage at L1 and L2 at the outdoor unit is not adequate, there's no sense in moving forward.
Right.
That voltage has to be rectified for the system to work properly.
Yeah, so you need some type of power conditioner.
Yes.
If you're in an area, and I've seen it on both ends. I've seen places where the voltage is just barely enough. And then I've seen it where it's high and there can be some spikes in there. But think about this. Think about any electronics. Most of us, a lot of people have flat screens TV now. Those are electronics. And those are going to behave to these power fluctuations the same way our equipment is.
Yes.
They're not going to like it. That's why you got to be careful if you're going to have a generator in your home that's going to control electronics.
Good point.
It's going to be rated for electronics. Of course. All right. So 208, 230 plus or minus 10%. And the voltage above that in the U.S. is 480. Yeah. Our equipment's 460. We're still within that plus or minus 10%. On the 460 volt units, generally speaking, do we send 460 to the control board, or does it step it down before that?
We step it down to 208, 230.
That's what I thought.
Yep.
Okay. So basically the 480 comes in.
Because the 460 is only available on the larger capacity commercial type outdoor units, which we typically have a transformer in it. So we don't have to change all the boards. Now, there's certain boards that we send a 460 volt to it. But for us to use the control board and like the power supply board, we step down that 480 or 460 down to 208, 230, so we can use those circuit boards and not have to change them.
All right. So 208, 230 single phase, or 208, 230, or maybe 460 three phase. Again, it depends on the model.
Right. And that control board does not generate DC voltage. That DC bus is generated at the inverter board.
Correct.
Right.
Right. But that voltage is important. There's a direct relationship between the incoming voltage
Absolutely.
and the bus bar voltage.
Because there's a connector. It's a hot pink connector on the control board. And you can, I tell the students, you can almost see it a mile away.
Yeah.
It's a hot pink color. And that's what we call that CNDC. CN for connector, DC for the type of voltage found on that connector. Right. So if you have 208, 230 at L1 and L2, S1 and S2, you should have 300 volts DC at CNDC.
Roughly. And it can be anywhere, it should be anywhere from 300 to 340.
Excuse me. Yeah, depending on the incoming voltage.
Yeah, and that's a DC voltage. Now, you mentioned it's a hot pink plug, and here's the thing about DC voltage. DC voltage likes to do one thing easier. That's how I explain it. DC voltage likes to do one thing. It does it a lot easier and quicker than AC voltage, and that is arcing.
Yes.
That's why a lot of times you see the plugs, there's an empty or a vacant
There's
pin.
a space.
Yeah, there's a space in there because it will arc. So listen to me, folks. Never, ever, ever unplug a DC power when the power is on, even if it's not running. Even if everything is de-energized and there's no call, if you unplug that hot pink plug, you will fry something.
Yeah, absolutely.
It will arc and you'll fry that board.
Because if you don't know this, DC positive, like Paul said, DC positive is always seeking ground.
Right.
So when you pull that plug out of that socket while it's energized, you run the risk of that arcing to land on your hand because you could be grounded to the unit. You could be leaning on it. So that's going to hurt. Or it's going to arc onto a screw that is holding that circuit board onto that panel.
Yeah, and I'm going to tell you from firsthand experience, it does hurt. It actually makes you swear.
Yes, it does.
It makes you swear.
In
I'm going to tell
some
you.
cases, it can turn your white skeevies brown.
Yeah, no, let's not go there. But I'm going to tell you, it's going to make the Pope swear. It really is. So 208, 230 AC coming in, we expect 300 volts roughly DC. And if we have 460 volts coming in,
that's
that's
the multiplier is 1.41,
Right.
which is about 600
about
volts
600
DC.
volts. Okay, so let's look at this from a troubleshooting point of view. I check my incoming power. Let's just say I've got 208 volts coming in.
Yep.
I go to measure my bus bar voltage. I should expect 300, roughly. I have 0 bus bar voltage.
Yep.
What should I be looking for next? What could be causing that?
Well, the way that I teach it is I show the flow, how the electrical flows through the boards. So if I don't have it at CNDC, going backwards, the first place to check is there's a CNDC at the inverter board. And that's the output of that 300 volts DC coming in to the control board.
Right. And what, no, I should have mentioned this before, but I'm thinking about the meter that I have on my truck.
Okay.
Is there anything I need for that meter, anything special about it that allows me to measure that high DC voltage?
Yes, you can use a megger or you can use a DC voltmeter.
Yeah.
It has to be capable of measuring high DC voltage.
Okay. All right. And again, the flow, Juan, you just mentioned the flow. And unfortunately, folks, those of you who are used to watching us on the YouTube, we don't have the cameras with us on this trip, so this is going to be strictly audio, and I wish we did because we could have put up a diagram. Yeah. But the boards are easy. They're power in and power out.
Yes.
Yeah.
Unless I have a replaceable fuse on that board, I'm going to measure the power in, and I'm going to look at the power out. If I don't have power out, then the board's the problem. If
Right,
I have
correct.
power out, that board is not the problem.
And that's how we teach it. We teach as inputs and outputs.
Right. Now here's the important thing. I said this at the beginning with the recent call that we just had. They had power in, but no power out.
That's right.
But they should have had no power out where they were testing it.
Yes.
Right.
There was a dry contact that didn't require it didn't have any power out. So you have to know what you should expect. And Will, is there anything in the manual that's going to help us with that?
Yeah, absolutely. I would recommend always referencing, and we tell all of our contractors who come into the classroom now, please go to your MPro. Go to MPro, look up your model number, go look at the service submittal, and go to those schematics. Check them out, read them, understand them, take time with them. Don't just assume that the part has failed.
Yeah.
A lot of times it's not the board. Boards get slaughtered by other components. And we went back and we were talking about line voltage into the equipment. Orlando has very bad power. Okay. It spikes up and down.
I think that happens in the whole United States.
Yeah. And so, voltage monitors, and the proper equipment attached to those units to prevent those boards from failing due to bad voltage or improper voltage inputs is always essential.
Most manuals are going to have a test point diagram. They're going to show you what the board exactly looks like, all the components that are on it, and what you should have there for voltages and so forth.
Absolutely.
And I just discussed this at an event in Vegas, and with the reporter I was talking to. Gone are the days when a technician should have in their brain all the knowledge needed to fix that piece of equipment. When I started in this business, Juan, it wasn't as long ago as you. Your license number is 7.
Exactly.
But when I started, if I went up to a condensing unit, I should know as an experienced technician, I should have the knowledge in my head how to fix almost everything that's there. I didn't need to refer to the manual back then, but we're in a point in time where it's not humanly possible to remember everything about every different unit.
Well, equipment is getting more sophisticated.
Right. And with more sophistication means, I don't need to know everything, but I need to know where to get it. So I look at that manual, I look at the test point diagrams, I'm going to measure the voltage coming in. Sorry, folks, if you heard that noise. Again, we're at the conference and somebody was just, I don't know what they were doing.
Food cart.
Right. Yeah. So I have voltage, line power coming in, let's just call it that.
Okay.
And no DC voltage. Did we talk about what could have been?
Well, you mentioned the fuse.
Yeah. Right.
And I need to mention this. So on the 410 equipment, more than likely that's a replaceable fuse.
Yes.
In the 454B or A2L equipment, that fuse is going to be braced in. So it may be bad, but you'll have to replace the board. But also the component on that power board that converts the AC to the DC is the rectifier.
Right.
So if you have no DC voltage at CNDC, you need to backtrack because don't forsake the connector or the wire. Because if the wire rubs a bare spot and touches ground, that DC voltage is going to go to 0.
Right. Now, that's another thing about DC that's different than AC. DC will not fry a fuse when it shorts to ground.
Spark.
It's not gonna blow a fuse when it shorts to ground. It's just gonna bring that DC voltage down to zero.
Right.
The exception here is the high voltage DC.
Yes.
Right? But low voltage DC, like 12 to 15 volts. We'll talk about that here in a second. But if I have 15 volts and I were to take that wire and ground it, it's going to go down to 0 volts.
Absolutely.
If I unground that wire, it's going to go back to 15
Yes.
volts DC. So it's not going to fry anything. So we need to know that. I actually remember a call many, many years ago on a 24 volt AC transformer on a furnace. And I had my meter on it and turned the power on. It's supposed to be 24 volts AC, and it had like 12 volts or 11 volts. And I said, wonder why it's like that. And then I had no voltage. And I had that smell that we all know, that burning transformer smell.
Yes.
So it took a minute for that AC transformer to fry. And we all know that smell. It's an unmistakable smell.
And something else to back to that transformer you're talking about. When I was on tech support, I used to always ask them, well, what's your voltage across R and C? And every time if they would tell me 24 volts AC, I knew they were lying because it's never 24 volts
it's
AC.
like 208. It's never 208.
Depending on the incoming.
It's going to be 211,
exactly.
214, 223. Yeah, when somebody's, I got it's 208. No, it's not.
Yeah.
Give me the actual volt. Take the reading.
So it could be a bad rectifier, it could be an open fuse, it could be a failed power board. So, and I mean, and this should not go without being said. You got to have the proper leads to test the connector.
Absolutely.
Yeah, and you need those needle leads or hypodermic leads, whatever you call them, because sometimes you have to piggyback into those plugs, and those are small. You're not going to get those test leads in there unless you got those hypodermic ones. They're worth their weight in gold.
Absolutely.
So, Will, anything else we should mention on this?
There's just some niche scenarios I've seen before where we've had tracers rub off the board. Wire exposure to the tracers rub through. They can be very hard to see. But yet again, you will see your input and output voltage between the boards. So it's just things to keep an eye out.
Yeah, and the connectors and the wires are important. Yeah, because you don't want to condemn a board if it was just a wire feeding it.
Well, and it's you'd be surprised how often you'd run across a wire that rubbed through. It's easily overlooked, and they automatically assume, it's a control board. It's bad. Yeah.
We know better, like the industry. The industry used to say, well, it's always the TXV. And my response to that is, no, it's not the TXV. It's the trash you're creating when you're brazing without oxygen, without nitrogen.
Yes. All right. So back to the 12 volts or the 15 volts DC. How do I get that? Where does that 12 or 15 volts DC come from?
That'll be coming out of our inverter board.
Oh, the power board.
Power board, excuse me.
Yes.
No, you're right. I mean, sometimes it's called inverter board. Some other times it's called power board.
Right. And what's the reason for that 12 to 15 volts DC?
That 12 to 15 volts DC is going to work as our network for communication and other components in the system.
Right. It's just going to basically power everything else that doesn't need 300 volts DC.
Right.
Because the only thing we need 300 volts DC is at the bus bar voltage. So then we'll talk about that on a later episode.
Right.
But that's so we can get the simulated three-phase power.
Correct.
If we were to send that everywhere, that would be
horrible.
That would be it would be horrible.
Absolutely.
So we step it down again in the board. There are transformers in there that step that down to 12 or 15 volts DC.
Whatever voltage, like LEVs require 12 volts DC and so forth. Thermistors require 3.3 or 5.
Right.
So, and then pressure transducers or sensors require 5 volts DC. So that 300 volts DC is always being stepped down to the lower voltages.
And am I imagining things, or is that plug typically labeled CNVDC or CNDC?
It's CNDC.
CNDC. That's what I thought. Yeah, CNDC, and that's pretty much across the board.
Yes.
Yep. Okay.
Pretty much.
And if we're missing, we got 208 coming in. We got 208-ish coming in. And we've got 300 volts on the bus bar. And if we don't have a 12 or a 15 volt DC on the board, what should we be looking for?
We should be looking back at our power board to make sure we're getting that voltage in and out. So our high voltage in, our low voltage back out, and anything in between that could be causing that issue.
Yeah, and again, no fuses. If there's no replaceable fuses, it's that board.
And typically, when the DC bus is missing, there's no LEDs.
Right.
Correct.
That's right.
That's a good point. That's when you kind of know.
Yep. And typically, because we're so used on the conventional side that if there's no LED, it's typically a incoming voltage issue. Well, you can check that you have incoming voltage, and that may tell someone, well, it's got to be the board. And it's not the board. It's because you're not getting that volts DC out of the power board.
Okay. All right. And then that's not it. We don't stop there. We don't stop at 208 or 208, 230, single phase or three phase AC power. We don't stop at 300 volts DC. We don't stop at 12 volts or 15 volts
Nope.
DC. There's still more voltages to look at.
Absolutely.
So what's next?
So, there's expected reading between 4.8 to 5.1 volts DC in other places. So if that's, again, if you're not, anything that's got to do with DC voltage, it's an issue typically either a connector or a wire or the board eventually, but you need to test where does that volts DC come from?
Yeah. And if you're looking at the diagram, look at any diagram for any unit. Look at the test point diagrams. What you don't want to do is condemn a board when it's something else, because when you condemn a board and you go out there with a new board, nothing changes.
Yeah.
Unless there's one exception. I've seen this happen a couple of times recently. In fact, talking to a contractor, they condemned the board and they ordered a board and they waited. I don't know how long they waited to get the board. They didn't have it in their truck stock. They ordered a board and they go back. Let's say it's at least a week. It's a week that the customer doesn't have air conditioning or heat or whatever. And when they went to replace the board, they noticed it was just a loose plug.
Yeah,
Yes.
that just happened to me last week in Dallas. I was getting the equipment ready to teach a class, and the branch controller was not working.
Yeah.
So I'm looking visually. I thought that all the connectors were connected. So I said, okay, it's got to be a bad board. So here I am, being typical. So I started to remove the board, and then I see that connector slip out of the socket. That's it. That's it.
Yep.
So it's a disconnected connector. So I plugged it back in, plugged everything back in, and everything worked.
Yeah. And you would have been likely to condemn the board if
Yes.
you didn't check that.
Absolutely.
Yeah. In fact, you like the rest of us. That's the first thing that comes to your mind. It's
Yes.
probably a bad board. Let me double check.
And it shouldn't be.
Yeah, it shouldn't be.
And this is very common. You get brand new equipment in, and you'll have a loose connector inside there. The guy's first thing they want to say, the board's bad. It came with a bad board.
Bad out of the box.
Yep, bad out of
Very
the box.
uncommon. Very uncommon.
Yep.
And then you kind of mentioned this in the beginning, but let's just go. Let's go to strictly M&P series products. Okay. All right. We have L1 and L2 coming in. That's 208,
First
230.
test.
Yep.
The first test.
And then we have S1, S2, and S3. Now, S1 and S2 are the 208, 230.
Correct.
And S3 is the communication signal. And between S2 and S3, you're going to get a bouncing DC voltage.
Correct.
And the way I used to explain it, Juan, is, and I'm sure you do something different, but I like the way you explain things to your students. You make it so easy to understand. But it's that S1, S2, it's bouncing.
Right.
It's the outdoor unit saying, hey, indoor unit, are you
Yes.
there? And the indoor unit saying, hey, outdoor unit, I'm here. How are you
Yes.
doing? And that's a continual
Absolutely.
communication.
So the way that communication happens, Paul, is when you power up the outdoor unit, 24 volts DC is immediately sent into the indoor unit through S3. And then only if that indoor unit sees that 24 volts DC, then it sends the 12 volts DC back to the outdoor unit, telling it, I see you, I'm here, I'm good to go, let's run.
Yeah.
But if it doesn't see that 24 volts DC signal, it is not going to send that 12 volts DC signal.
Yeah. When I started here 14 or so years ago, this was a very common call. There'd be nothing wrong. But S1, S2, and S3 are polarity sensitive. And here's the thing. They're color-coded black and white and red outside, and they're color-coded black and white and red inside. S1 has to go to S1, S2 has to go to S2, S3 has to go to S3.
Yes.
If you switch those, you're going to get strange readings.
Right.
Absolutely.
And
it's
that's
not gonna run.
And that's still a very common call we get. If Austin were here, he'd tell you that's still a call that they get now is crossed wires.
Yep.
Yes.
So keep those polarities sensitive.
And regarding that also, so if so I go a little bit deeper in troubleshooting that communication, and I tell them if you go outside on a system that is not running, and typically I would go to the outdoor unit first because that's where the 24 volts DC is an output from the outdoor unit. So I would take my voltmeter and measure between S2 and S3, and if I have 24 volts DC, everything outside is good. But it should be fluctuating, and it's not. So there's a problem between the outdoor unit and the indoor unit.
Right.
So at that scenario, I would go indoor unit and measure the voltage across S2 and S3. If I don't measure 24 volts DC, what's my problem?
It's the wire.
The wire or the connecting point.
Or the connecting points. It's
Yep.
something, it's a connection or it's a wire.
And there's multiple calls that I've been on that's been bad wires.
And similarly, because if that wire gets shorted, actually, no, it won't go with it, but it's got to be a break in one of those
Right.
wires somewhere. But if you go between S2 and S3 and you have 0 volts DC, first thing I would do is I would turn off the power, disconnect S2 and S3, power it back on, and I would check the voltage between S2 and S3. If I still have 0 volts, then my problem's in the outdoor unit.
Right.
Right.
But if I have a steady 24 volts, then there's a very good chance that wire is grounded.
Right.
The S2 or S3 wire between the indoor and the outdoor unit. So I'm going to go back, I'm going to connect it back up. I'm going to go inside, disconnect S2 and S3 inside, and I'm going to just do a continuity check
Right.
between S2 and what I'll do is I'll take S2 and S3, power's off on everything.
And that communication across S2 and S3, it's always fluctuating or
Right.
bouncing whether the system is running or not.
Correct. It's anytime it's powered on.
Yes.
But if I had 0 volts with it on, and I disconnect this to I have 24 volts, so I'm looking at the wire now. I'll take S2 and S3, disconnect it, both indoor and outdoor. At one of those ends, I'll take S2 and S3 and put it together.
Yes.
I'll go to the other end and just ring it out.
Yep.
Yes.
And if I get no open,
continuity
or no
test.
ring, no
Continuity test
continuity,
doesn't lie.
then it's that wire.
Yep. Anything else, Will?
As far as it goes with S1, S2, and S3 terminals, I feel like those are probably some of the most common overlooked installation steps in the entire process. And it can be just as simple as you didn't tighten the lug down hard enough,
Right.
you know? And guys get confused. They immediately assume, oh, look at this junk, and they want to pull it back off the wall again. But, you know, just as it is a problem with that, it's also a problem with, you know, just double checking the work when it's through.
Right. And wire gauge makes a difference.
Absolutely.
Yes.
You got to be
Yes.
careful, especially if you're dealing with stranded cable,
Yes.
how you strip that wire, because if you cut any of those strands, that you just change the gauge of the wire or the
Absolutely.
size of the wire, and that can create communication issues.
And guys love to trim down the wires. Do not
Yes.
trim down the wires. Just please refer to
just
your,
to make it fit on the connector.
right. Yes, just to make it fit in the connector. I would definitely be referencing your manual on the equipment or your submittal before installation.
Yeah,
Make sure
and
you
some
have
of the
right
error
wire.
codes that are displayed on with that issue, with that communication, it can either be a 6607 or an E6 at the wall controller,
Yes.
or a 2502,
2502, yeah.
which is a communication
Right.
issue.
And we mentioned the temperature sensors, the thermistors, and they're going to plug into a specific spot. The plugs are going to listen. The wires, the connectors at the end of the wire, and the plugs are usually the same shape and size and color.
Yes.
Right? It's
Oh, I love me.
there are some exceptions.
Yes.
There are some that are the same shape and size, but different colors.
Yes.
But they should for the most part match the color on the
Yes.
board.
Yes, absolutely.
So if you have a red pin and it's plugged in, or a red wire connector and it's plugged into a green pin, something's wrong.
Yeah,
it should be a red pin typically. And some of the common sensors, well, there's an outdoor ambient temperature.
Yep.
There's the discharge temperature, which I think is one of the most important readings you can get in a refrigeration system. There's the outdoor coil temperature, and then there's the indoor air temperature. There's the coil temperatures. We're measuring the temperature at the inlet of the coil, the outlet of the coil typically.
yes.
Room temperature, which
Room
is
temperature,
returned.
yeah, we mentioned that, outdoor temperature. And you've already mentioned this, how to check them. It's an ohm reading.
Yep.
Correct.
right? But you still need that voltage on there too.
Yes.
So with them connected, take your needle leads and check for the voltage on there. It's, for me, my experience has been most of the time when I find a bad thermistor, it's either an open or a short.
Yes.
But they can change value. They can break down, especially if they're in the weather, if they're in the elements, hot temperatures, cold temperatures, changes in humidity, changes in, whatever. They can lose their value.
Yes.
So if it's 70 degrees, I'm just going to pick a random temperature.
Right.
If it's 70 degrees, it may think it's 50 degrees, and that's going to throw everything off.
Right.
So again, in the manuals, there's a chart that you're going to find the resistance, and it tells you what the temperature should be.
And you have an option. I mean, you can either get you a glass of ice water and dip it in, because that's typically 32 degrees,
Right.
or measure the temperature around the thermistor so you know what temperature to resistance values to look for on that chart.
Yeah. And they can be, I think one of the values here is a 15K to 20K ohm reading at 77. It should be at 77 degrees, just as an example.
Yep.
Correct.
And they're all negative coefficient thermistors, meaning
Correct.
that when the outside temperature is, or the surrounding temperature is high, the resistance value is low,
Right.
and then vice versa. And each thermistors, when they fail, typically the system gives you a specific fault code for that one thermistor.
Correct. Yep.
All right. What's next? Are we done?
Nope. Okay, so the further testing is we need to look at the inverter circuits and the other circuit boards that may be there, but we're going to cover those in the following podcasts.
Right. And we'll save like the compressor, the UV and W, because that's going to be the same no matter what.
Right.
We'll save all that for the last podcast. We'll just finish it up here.
Great.
All right.
All right.
So you
Good
ready?
one.
You ready to go try some Rocky Mountain oysters?
I know.
No.
That is a definite.
Well, let me
no.
ask you something. Do you eat octopus?
Sometimes.
Yes, I do. I love
Yes.
octopus. Do you eat tripe?
Yes.
Yeah.
See, I don't like tripe. I won't even try it.
As long as it's fried.
Yes.
My
I
mother
won't
used to
like
make.
it
It's got to
baked.
be.
My
fried.
mother used to make a soup, like a
It's
stew.
got to be crunchy.
No. Do you like blood sausage?
Oh, I love
Yes.
blood sausage.
Me too, but it's got to be overcooked.
Yes.
Yeah.
It's got to be.
Crunchy.
Yeah, it's got to be crunchy too. What's the other food? Liver.
I love liver.
Oh, see, I don't.
I love liver. As a matter of fact, I told my wife last week I've been craving beef liver. I eat chicken livers all the time.
Yeah.
Yeah.
I love it.
Wasn't that your nickname, Chicken Liver?
Chicken liver.
Yeah.
I've been called a few different
Okay,
things.
so I guess before I start criticizing Rocky Mountain oysters, which I have no intention of ever trying, there are plenty of other strange foods that
Yes.
I know. Some people look at us eating lobsters, and it's like, when I was in Japan, there was a package you could get. Somebody got me it'd be like if you get a package of like candies, like snow caps or something,
Yes.
right, or Raisinets. Well, this was one of those, except it was grasshoppers, real bugs, sour cream and onion grasshoppers. So,
Wow.
you know what they tasted like? Sour cream and onion.
Another thing that I love, back in the day, I used to drink, not drink, but eat anchovies on saltine crackers.
Oh, I don't like anchovies.
Oh, that is good stuff.
Way too salty.
Salty to salty.
That's all right. All right, everyone. We'll see you on the next one.
All right, everyone.